Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.7, Special Limits. Now we're going to talk about a few different special limits today, but one that the AP test really likes to ask in the multiple choice section is something like this. Limit as x approaches 2, the absolute value of x minus 2 over x minus 2. Now we can see when we try to plug in 2, definitely I'm going to get 0 over 0, which means something funky is happening here, and maybe we can simplify that. And actually algebraically we can, but honestly I think the best way to do this problem is to picture what it would look like on a graph. So that's what we're going to do. Best way to graph this, we'd plot some points. Certainly we know when we try to plug in 2, we get 0 over 0, so that's undefined. Let's see what happens when we plug in numbers around 2. What's our function do? Let's check out 3. If I plugged in 3, I'm going to get 1 over 1. That simplifies to just 1. If I plug in 4, I'm going to get 2 over 2. Also reduces to 1. I plug in 5, I'm going to get 3 over 3, which also reduces to 1. The absolute value doesn't do anything when I plug in values bigger than 2. So if I go to my graph, I know when I plug in 2, it's undefined, so that's going to be an open circle. And every single value that I plug in that's bigger than 2 all evaluates to 1, so it's just going to be a horizontal line at 1 pointing out to the right. Now, when I plug in values that are less than 2, we'll see the absolute value plays an important role. If I plug in 1, it's going to evaluate to negative 1. When I plug in 0, I'm going to have 2 over negative 2, which will evaluate to negative 1. And when I plug in negative 1, I get the same thing. I'm just going to have 3 over negative 3, all evaluating to negative 1. So again, undefined at 2, but all the values to the left of 2 evaluate to negative 1. So I'm going to have a horizontal line pointing to the left at negative 1. Now, picturing these graphs makes it easy to evaluate any of our limits. The left-hand limit as x approaches 2 of this function, we can see that it's clearly on that horizontal line at negative 1. So our limit will be negative 1. The limit as x approaches 2 from the right of this function, now we're just jumping on the right-hand side of this graph, and we're going to be on the horizontal line at 1. So our limit's going to be 1, which, bringing us back to our original limit, since the left and the right side don't agree with each other, our overall limit does not exist. Now let's transition to a couple trigonometric limits that are pretty common that they like to throw at you on the test. I'll have the limit as x approaches 0 of sine of x over x, and the limit as x approaches 0 of 1 minus cosine of x over x. If we actually tried to evaluate these by plugging in 0, you definitely see we get 0 over 0. And on the right, we'd get 1 minus 1 over 0, still 0 over 0. Which means something weird is happening here, and we don't really have a algebraic skill set that's efficient to answer these. So the best way to visualize what the answer is, again, is going to be look at the graph. So you can see if we graph this sine of x over x function from the left and from the right, our graph is approaching a y value of 1. So that is going to be our limit, even though our function is undefined at 0. Our graph is approaching a y value of 1. And on the right, our 1 minus cosine of x over x function, we can see from the left we're approaching a y value of 0, and the right we're approaching a y value of 0. So this limit evaluates to 0. For now, it's just better to have these two limits memorized. In the future, a few weeks later in the class, you're going to develop skills to actually evaluate these algebraically, which are super efficient and super fast. So you're never going to have to memorize these 3 weeks from now. But at the moment, let's use these facts to evaluate these practice problems down below. The limit as x approaches 0, sine of 5x over x. Now I want to use that fact up above that we established, but in order to use it, I need what's in the sine function to be the same as the denominator. And since we have a 5x down here and not a 5x in the denominator, I can't use that fact up above. So what do? We just make the 5x and the sine function match the 5x in the bottom by multiplying the whole fraction by 5 over 5. Now we can rewrite this limit, isolating that sine of 5x over 5x portion, knowing that the limit of that from the fact above is going to equal 1, And now we just end up with our limit equaling 5 times 1. So 5. If we check out this last example on the right, the limit as x approaches 0 of 1 minus cosine squared of x over x, we can see it looks a lot like the fact from above, but it's cosine squared. So there's a couple different things we can do about it, but since it's a difference of squares, I'm just going to factor that numerator. So 1 minus cosine of x times 1 plus cosine of x all over x. All right, similar to before, we're going to isolate the fact that we see above, the 1 minus cosine of x over x, effectively splitting this limit into the product of two limits. So the limit as x approaches 0 of 1 minus cosine of x over x times the limit as x approaches 0 of 1 plus cosine of x. Right. Now we know from the fact above that the limit on the left is equal to 0. And the limit on the right, if we plugged in 0, would be 1 plus 1, would get us 2. But ultimately, altogether, this limit would evaluate to 0. To see more videos like this, click subscribe. Or to continue your journey through calculus, click the next video on your left.